This is the solution video for problem 2 of problem set 5, and in this problem I'll basically be implementing the function f of x, y, z using a number of different MSI configurations. M0, M4, M6. And here I need to solve it with a 3 to 8 decoder and one gate. So this one I immediately just think, well, I've got 3 input variables, so that's going to be my inputs to my 3, and the one gate's just going to be my OR, because I'm just going to be ORing all of my midterms together. So I'm going to have my 3 to 8 decoder, and it's going to have inputs of 0, 1, and 2, and now output 0, 1, 2, 3, 4, 5, 6, 7, and X is my most significant bit, and then Y, and Z. I'm going to want to OR M0, M4, and M6 together, and that completes part A. That was easy. B. Now I need to do with a 2 to 4 decoder and a gate. Now this one's a little intimidating. I don't think I can't do this one just off the top of my head. So what I'm going to first do is I'm going to write out my midterms. So f of x, y, z is equal to x bar, y bar, z bar, or x, y bar, z bar, or x, y, z bar. So I need to come up with an intelligent way to group these together, and hopefully I find something ingenious. So, well, I have x bar, x, x. That's not really going to do me much good. Got y bar, y, y. Z. Okay, so they all have a z bar on them. So let's try to separate that out. So I got x bar, y bar, or x, y bar, or x, y. And I'm going to be ANDing that with z bar. So right now I've got a set of midterms ORed together, and I'm ANDing that with a z bar. No, that's not looking so hot. So something we could try is something we can always do with the decoders is, rather than use an OR gate, we can try using a NOR gate, in which case we're going to be finding the complement of all of this. So I'm going to double complement this and see what I can get into a NOR shape. So we're going to double complement it using involution. And let's see what we get. So we're going to have x bar, y bar, or x, y bar, or x, y, NORed, sorry, it's going to be NORed with a z. And so all of this is 3 midterms. So the complement of all this is the midterm that's missing. And so, I need this complement here. And so essentially this is the form I need it in. So rather than take midterms 0, 2, and 3, I'm going to take max term 2. And so that gives me my expression, hopefully, I think. And so I'm going to take max term 1 or with z. So this is my 2 to 4 decoder. Z, y, oh, no, sorry. X and y, I don't need z. And I'll have 0 and 1. And I'll have 0, 1, 2, and 3. And so I'll want this one, because that's not included in here, so this is going to go into there. And z will go into there, and that's my f. Finally, next I need to do C with a 8 to 1 mux. And so this one, again, this should be fairly straightforward, kind of like this one, kind of like part A. This is where do I put ones and where do I put zeros? So I'm building an 8 to 1 mux. I'm going to need 0, 1, 2, 3, 4, 5, 6, 7. S2, S1, S0. And I'm going to want to use X as my most significant bit, Y, and Z. And for my 0 through 7, I will want a 1 at minterm 0, a 0 at minterm 1, minterm 2 is 0, minterm 3 is 0, minterm 4 is 1, minterm 5 is 0, minterm 6 is 1, and minterm 7 is 0. And that's my F. And just need to grab one more sheet of paper to solve part D. And this will be, I have to do this again with a 4 to 1 mux and no other gates. Well, that'll be fun. So again, I'm going to need to think through this. So I'm going to try X bar, Y bar, Z bar, or X, Y bar, Z bar, or X, Y, Z bar. So those are my minterms, and now I need to come up with a way to group these together. And so if I use X and Y, I really can't factor anything out. And so I'm going to need to be putting Z complements in, and that's going to require a gate. So I can try Y and Z maybe. I'm going to have Y, Z bar, Y, Z bar. Oh, so I'll have X and X bar, which will be 1. And then I'll have Y, Z bar with X, so I actually won't need to complement the X, and these will be taken care of by the minterm generation function of the mux as my select bits. So let me just kind of make this a little more explicit what I'm doing. So this is X bar or X, Y bar, Z bar, or X, Y, Z bar. This is also, I can also basically essentially add 0 with the Y bar Z, or 0 with Y, Z. And so I'm going to be putting zeros into these minterms, X into this one, and 1 into this minterm. And my 4 to 1. So 4 to 1 mux, 0, 1, 2, 3. And I have to have 2 select bits, S1 and S0. And I will put Y into the more significant bit and Z into the less significant. And so for Y bar, Z bar, which is 0, I'm going to be putting a 1 according to this function. Z bar is 2, so I'll be putting X into that one, and I'll be putting 0 into the other 2. And that completes the function for part D.